Hello friends, my name is Girish Shirodkar and in today's session we are going to learn about moment. Now, as far as worldly definition of moment is concerned, it is something force multiplied by the perpendicular distance. But I can make out that this definition is not sufficient to understand the significance of moment. So I will perform a small experiment here only in my house, and I will demonstrate to you what the moment is, and after that we will go for the theoretical explanation of moment, and then we will learn some significant cases of moment. Stay tuned. Friends, my name is Girish Shirodkar, and in today's session we are going to learn about moment and its application. To understand the significance of moment, let me take you to our door. This is our door, which is more than 1 meter in width, slightly larger than the normal door. And if you apply force here, let me apply force here. You will notice that when I apply force here, the door turns. But the force which is required to be applied here is lesser. But if I apply force here, you will notice that the force you require here to turn the door under similar circumstances is more. If you apply force here, still you require more larger force. The force is still larger, very large, extremely large. So as you go closer, the force required to turn the door goes on increasing. So this is called turning effort or moment. And friends, now we will have a discussion on moment. Friends, in this video we are going to see how moments are taken, what is moment, and how the moment is taken of a given force. To understand the meaning of moment, friends, let us consider a force, say force F, and let us consider a point here. Let us call this point A. Now the moment of force F, this force about A, is nothing but the force multiplied by the perpendicular distance of the force from the given point. So this is the perpendicular distance of the force from point A. Now what do you mean by perpendicular? Perpendicular distance means it is the distance which is at 90 degree from A. So the moment M will be given as F multiplied by this distance, let us call this distance D, F into D. Now, in order to understand the sense of the moment, whether it is clockwise or anti-clockwise, positive or negative, now you should know that clockwise moment is taken as positive and the anti-clockwise moment is taken as negative as per my convention. So how to know that? To know that, see, this is the perpendicular distance from here to here, and this is the given force. In place of perpendicular distance, you put something, say pen, and here is the point A. The point about which you are interested in taking moment, that point is here A. So what you do, you apply some force to this in this direction. It can be applied this way or it can be applied this way also, this way or this way. Say if I apply it this way, if I hold it and apply it this way, this will start turning in the clockwise direction about A. The pen will start turning in the clockwise direction about A. So the moment in this case is positive. If it had turned in anti-clockwise direction, the moment should have been negative. So one thing is clear, that the moment implies rotation of something or rotation. Fine, let us take an example now to understand it more clearly. Say there is a force here, say 40 Newton, and here is a point. A, and these two distances are given now from A. This is say 14 meter, and this distance is also given, which is say 10 meters. Now you can easily make out that out of these two distances which are 14 meter and 10 meter, 10 meter is the perpendicular distance, perpendicular. So only 10 meter you are going to take because it is a perpendicular distance, and the moment about A will be MA is equal to the given force 40 into the perpendicular distance, which is 10. Remember, 14 is also the distance of the force from the given point, but it is not the perpendicular distance. You have to take only that distance which is perpendicular. So 10. Moreover, to check the sense of the moment, now from here to here, this is the perpendicular distance. So you put pen here and check in what direction this is going to rotate. You will find that this is turning in clockwise. So give positive sign. And the friends, sense of this moment will be, as I said to you, it will be clockwise. So plus. Well, let us take one more example. Say there is a force here, and here is the point. Say force is say 10 Newton, and you are interested in taking moment of this force which is 10 Newton about point say B. So in this case you can easily make out, see the moment needs two things. First is the force and the other is the perpendicular distance. Since perpendicular distance, if you take this distance from here to here, it cannot be a perpendicular distance. If you take distance from here to here, it cannot be a perpendicular distance. So in order to get perpendicular distance, in this case, you should extend the line of action of this force. Just extend it. If the given force does not give you the perpendicular distance, extend it. That extension, that line of extension is called the line of action, and now the perpendicular distance will be this. Let this distance be say 2 meter, and now the moment will be, moment of 10 Newton force will be M about B is 10 multiplied by the perpendicular distance of 10 Newton from B, which is 2 meter, and the sense will be, in place of this perpendicular distance, put something and hinge it at B and check in which direction this is turning. You will find that if you apply force here and you pin it here at B, it starts turning in anti-clockwise direction. So the moment in this case will have minus sign. So answer is minus 10 into 20, that is minus 20. Force is measured in Newton, the distance is measured in meter in this case. So minus 20 Newton meter. Friends, let us move further. Say for example, now I'm going to teach you about one very, very important principle and which needs to be understood. Say there is a force here, F, and there is a point here, let us call it A, and this perpendicular distance in this case is say D. The moment will be F into D, moment about A will be F into D, and the sense will be, as you can easily make out, put it here, put something here, and in place of A you pivot, and F, at F you apply force. See, it is turning in the clockwise direction, so the moment will be positive in this case. However, now you try to move this point A closer to F, you will notice that D is becoming less. When you move A closer to the force F or its line of action, the D becomes smaller and smaller and smaller. And when A lies on the force itself, when the point A lies on the force or its line of action itself, the moment becomes zero. So when the moment becomes zero, when the point about which you are taking the moment, when that point lies on the force or its line of action, the moment becomes zero. So I will write here, when the point about which the moment is taken lies on the force or its line of action, the moment is zero. So the moment about that point is zero. Now let me elucidate this. Say there is a force here, say 10 Newton, and the point A lies on it. Without doing further calculations, you will directly write moment about A is directly 0 Newton meter, whatever. Let us take one more example. Say there is yet another force. This is that force, and point A lies here, about which you are interested in taking moment. This force is say 8 Newton. The moment will be moment A, 8 multiplied by, now see, you can extend this line to check. It passes through A. The line of action of 8 Newton force passes through A. So without doing further calculations, you can directly write MA equal to 0 Newton meter. So this principle simplifies your calculation. If any point lies on the force or its line of action, the moment about that point automatically becomes zero. You need not do any further calculations to understand that.